So the first thing to talk about in this approach to statistics is what is a probability distribution. Probability distribution, all it does is it assigns values to the outcomes of the events in a sample space. Okay. Now, outcomes, when we're talking about stats, could be numeric. So, for example, a roll of a dice is a common sort of stats problem. But it can be categorical as well. So not actually a number. So the example I put there is blood types. So different categories. We're interested in looking at these things called random variables. So a random variable is actually a function. We've been doing a lot of work on functions. The value of that function will be a number, and it's determined by the probability of that outcome. So that's how probability ties into the statistics. Now, some notation. Random variables, we usually use an uppercase letter to represent a random variable, and the lowercase variable is the value. You'll see what I mean by that in a sec when we look at an example. Random variables can be continuous. They're continuous if all the outcomes are like in an interval. So there's some actual interval, and you could pick any value in that interval. So you might be able to get, what's an example of a continuous one? Maybe something like the height of a person. When theoretically, you could keep breaking it down to smaller and smaller and smaller units. Whereas they could also be discrete if that range is what we call countable. So we could actually count the number of possible outcomes. The interesting thing about that is you can still have an infinite number of outcomes. Wow. How do you count infinity? It's what's known as infinitely countable. So theoretically you could count them all. So a discrete sample space, an example I've got there for one of those ones that would be infinitely countable, going to a rolling of a dice, but if I'm interested in how many times the dice is rolled before I get the number 6. So there is an infinite number of possibilities there, because theoretically I could keep rolling and rolling and rolling and never get a 6. So there's an infinite number of possibilities, but the range is discrete because I couldn't roll the dice 1.5 times. So they are discrete values. I could do it once, I could do it twice, I could do it 3 times. A coin is tossed 3 times. Our random variable is going to be capital X, and the definition of our random variable is going to be the number of heads thrown. So tossing it 3 times, number of heads thrown. So our sample space would be that. There are all the possibilities there. Head, tail, and so on. That would be the sample space. The sample space of X would be, well, X was, a coin is tossed 3 times, the number of heads thrown. So it's not head, but it would be 3. 3 heads thrown. Head, tail would be 2, and so on. Notice it's not a set, because if it was a set of possibilities, we'd say, oh, it's 3, 2, 1, and 0. It's a sample space, so it's saying all the possibilities. So we can get 3. There's 3 different ways we could get 2. There's 3 different ways we could get 1, and so on. Well, we draw that up into a probability distribution table. So there's our probability distribution. And this is what I'm meaning by capital X and little x. We're saying, what's the probability that X equals little x? Now, little x is all of those possibilities. Could have been 0, could have been 1, could have been 2, could have been 3. We're saying the probability of it being 0 is 1/8, of it being 1 is 3/8, and so on. We could put that in a graph if we wanted to. So it's a simple little graph there. So that would be the graph of the probability distribution. So some properties of this function. Got to be greater than or equal to 0. You don't get a probability that's negative. The sum of all the probabilities, that's what we're basically saying there. Well, we've seen that in probability, that has to equal 1. If it turns out that the probability of X equaling X was the same for every possibility, then that's what we call a uniform distribution. It's spread out uniformly. And that's where I'm going to leave it for today. Okay, so just a quick introduction into what these random variables and things like that are.